All right, is the lighting okay or is the window open a little too much at the back? You're good? Okay, cool. We finished up the sphere class. We modified, excuse me, we modified the sphere class such that instead of the spheres having an x, y, z attributes, we created a single point 3D class that stored that information, and then the sphere had a point 3D. And the idea of this was to encapsulate all of that like point 3D functionality and data into its own class, but also if we started making other shapes that would need to make use of like a point 3D stuff and that functionality, well, it already exists as a class, so it's perfect. And if we were to go and start writing tests for this, like, okay, look. It's probably becoming clear. I mean, I've been emphasizing it. If you were in lab yesterday, you would have experienced it. But like the assert tests, like we are really starting to hit the limit of how, when I say usable, I don't mean that the assert tests are insufficient. That's not what I mean. But they become more difficult to work with. The assert tests are tricky to work with. And like our tests now need to have like some setup code that can be run. I mean, it's simple stuff, but like we need to make an instance of a sphere before we can actually test anything. So there's some setup code. And if we want to make a point 3D, okay, actually in order to make a sphere, we need to also make a point 3D object. So we need to make a point 3D object that we need to have in order to make a point, or to make a sphere class that we can then test. So like there's all this extra setup stuff that's getting required. And it's difficult to start to tell the tests apart. I mean, we've just got like these walls of tests at the end, right? Like assert, assert, assert. And like before, when we had a series of assert tests under a single function, yeah, it was obvious. All those tests were related to that function. But now like we're testing a whole class and there's all this different functionality and crap that's going on that we're testing in this giant wall of assert tests, which is becoming a problem. It's also not easy to tell what the test is doing. Like, yeah, you can piece this together, but like assert 0.01 apps of the sphere distance between sphere, like it's getting hard to, like it's becoming less clear. Like the lines of code are getting complex enough that it requires some like parsing in your brain to know what the hell this test is doing. Like it's not as explicit as it once was when like the tests were simpler. It's also getting hard to get a sense of how thorough the tests are. Like, what do I say here? We have tested the distance between sphere objects, but maybe I should test the distance between if the sphere object are in different like octants, like which is the 3D equivalent of like a quadrant, right? Like, oh, test the distance between spheres. If the sphere is at location like 1, 1, 1 and 10, 10, 10, right? What's the distance? Well, what if they're like, is that sufficient? Should I test if like the spheres are like this, or one's over here, one has some negative value? Like I'm starting to think like there's a lot of different cases I need to start to cover for testing these spheres and this functionality. And now we're going to start getting like a lot of duplicate code, and that wall of assert tests is going to get really big. And that's not necessarily bad, but it's a pain in the ass. So what we're going to cover now is a bit of a shift to a much more flexible, usable, robust, a lot more like built-in tools that are going to be helpful, like a much better way to write tests for our code. And it's, you know, a lot of languages have their own version of this type of thing. Here we're using something called Unittest, which is built into Python. When you download Python, Python gives you Unittest. It's like a library designed to help you write tests and write tests in an effective way. It's going to feel really like obnoxious at first, like it's like really verbose and whatnot, which it is, but your tests are going to be so much nicer and so much clearer. And this scales a lot better as our software gets bigger and more complex. Where the assert tests start to like, that wall of like assert tests is going to get bigger and bigger and bigger. It's going to get crazier and harder to follow. Where the unit tests, if you do it this way, it might feel like you're doing a lot of work, but in the grand scheme of things, it's like less work. It's hard to see what I mean at this stage, but trust me. Other languages, like next semester we're doing Java, we have the same idea that we're going to be using in Java. It's called JUnit. And this one's called Unittest. In Python, there's another one, but it's not like built into the standard library called just like PyTest, which is also really handy. Some people prefer it to Unittest, but that would require some extra like work to get running. So we're just going to use Unittest because it's sufficient and it's fantastic. So yeah, okay. Our simple assert tests are becoming more difficult to work with and to write. Like circle, point 3D sphere classes, there was some setup code required. Not a lot, but you know, it was a thing. The assert tests get jumbled together. It's not easy to know what each test is doing. It's difficult to wrap your head around. So Python does provide us with the tool Unittest, and it provides a lot of functionality. It has a lot of special asserts. It's got a system for like automated testing. It has shared setup code and like shutdown code. It has this ability to do like subtests. It gives you nicer results. So like with our cert tests, the program just crashes. And you don't really know why, and you kind of have to go do some digging. But with the unit test, it'll be like, I crashed here. Well, another thing, like if I've got like 10 assert tests and the third one fails, it just stops on the third one and it doesn't tell you really why. You just kind of go do some digging. You know, not too bad. But with unit test, if the third one fails, it'll still run all the tests and tell you the third one failed. And it'll like tell you why. It won't just say like, I failed. It'll be like, I failed because I was expecting the number 17, but I got back a 14. And you go, oh, okay. So it's a little bit more detail there too, which is really nice. And this list goes on. And you could have a whole course on writing unit tests. And before anything too, I want to make clear that writing unit tests, it's the same story from the beginning of the semester when we were talking about our assert tests. Writing good tests is almost more of an art than a science. So you only get good at it by doing it. And whenever you ask the question, is this enough? I don't know. That's up to you. Is it enough? Did you catch all the cases of the things you need to test? That issue is going to persist here. This is something you just got to work on by practicing. But we got to be writing these unit tests. If you don't write your unit tests, like on assignment 4, I give you the unit tests, right? So whatever. But in general, whenever you're writing code, like it was the case before in this semester with your assert tests, except, you know, in practice, people aren't doing the assert tests, they're doing something like this. If you write code and you don't have corresponding unit tests for your code, you have incomplete code. Like no one, like you're not done. Like let's say this was next semester and I'm like, okay, write your code to do this, and you give it to me and there's no unit tests, you submitted an incomplete assignment. Like, and it's not like, oh, you just didn't do the unit test part. It's like, no, your code is as good as useless to me. It's your job to write the code and demonstrate to me via the unit tests that your code is also correct. That's what I mean. So giving me code without unit tests is equivalent to giving me nothing. You write the tests, otherwise it's useless. All right, so yeah, we're only going to scratch the surface. And to be clear, don't let this intimidate you. There's like a very systematic approach to how you write these tests, so it's not too bad. We're only going to scratch the surface of what we can do here. I'm only going to scratch the surface. We have a limited time. These are immense packages with a lot of flexibility and tools built in that you can do a lot with. But I'll show you like the core, most important stuff, I'd say. Any questions about any of this motivation before we keep going? Okay. No, was that a question? Just a scratch.
What if you had, like, say you're trying to solve something a bit more complicated, like a math problem,
Yeah.
with vectors and spaces, like, how do you go about writing those kinds of tests?
It would depend. I can't. That's too abstract to answer right now. But the answer is you just do. Okay. You figure it out. If it's still at the end of the day, if it's like you're writing a function that takes inputs and outputs, if you're writing the function, well, you know how to calculate, how to map the inputs to the outputs as a human. So you can know, like, well, based on these inputs, I should get this output. So you write the test to match that. And then you write the function. And did it work? Yeah. All right, starting a unit test class. So Now, one of the reasons why we didn't start talking about unit tests earlier in the semester was, well, I want you to be sufficiently experienced in coding so you can write these things without too much trouble. It also, by this stage, there's a hell of a lot of good motivation for why unit tests are a superior strategy to just the simple assert tests. But figure, the assert tests are fine and sufficient for the early stuff. They're sufficient for this stuff too, because really unit test just effectively uses the asserts under the hood. But also, it would be difficult for me to be like, start writing class sphere tests, and you're going to say, what the hell's a class? Well, now we know what classes are. So we write our unit tests in a class. So we define a class for what we're going to do. First thing you'll notice at the top is import unit test. Yeah, it's a package. It's existing in the standard library, but it doesn't load up by default. We have to import it. Then we say class sphere test, and that's a great name. What am I testing? The sphere class. So we say sphere test. We follow camel case there, so we're good to go. Also, here's a funny thing that you haven't noticed before, and I'm not going to get into the weeds of this right now. I'm going to tell you what it is, and if you're going to say, tell me more, I'll say stay tuned for 162. But you'll notice next to the name of the class, sphere test, it's got parentheses. Kind of like how functions had parentheses, but we never did that before. But we have parentheses that say unit test.testCase. What this means is, someone wrote, there is a class in Python that has all of the code and functionality and crap you need to run the unit tests. Somebody wrote that code. And the way to get it to work is basically what you want to do is you want to take that existing code and you want to effectively take that code and start adding a little bit more code below it in the same class, right? So unit test is a class, okay? It exists, and it's a class. It was defined in a class, kind of like this. And there's all this method and whatnot in there, and we're going to call these methods shortly. And in that class is everything we need to write our unit tests and do everything effectively. And then what you got to do is you need to take your specific tests that you want to write, and you need to add them to the end of that class. But you're not going to do that. You're not going to go load up Python's unit test class and start hacking at it to change the class to add your own code. That's ridiculous. But that's kind of what you have to do to make it work. So what we do is it's kind of like an import, where what we do is what that basically says is tack this on to the end of that class, but we're giving it a special name. That's it. It's kind of like an import. Import this whole class such that it's like I'm appending this to that class with my new name called the sphere test. Yeah, there we go. Yeah, that's the idea. It's called an inheriting. Okay, we inherit all of the crap that exists in the test case class, and we're just going to pretend it exists in my class. Even though there's no code there, it is there. Kind of like an import, okay? But instead of an import, this is adding the contents of the class to your class. If you're left going what? It doesn't matter. It's the magic code you need to make it work for today, okay? So, in the above example, you would see the import and the start of the class. Although it is not needed on Colab, depending on how we have our test set up, we may need to import the class being tested. Right. So raise your hand if you're not using Colab in this course when writing code. So you'll need imports if you've got this written in a separate class or separate file, which is entirely what you should do. You just need to make sure you're importing it. If you are doing everything in Colab, don't worry about that. As a convention, we always call our test classes some class test, where some class is the name of the class that we're testing. Sphere test, point 3D test, circle test, person test, whatever it is, that's what we would call it. That's just a convention, though. You will also notice the unit test.test case with parentheses next to class name. The nuance of what this means is outside the scope of the course. In short, we need it to make the unit test work. That's it. Okay, it's the magic code. I hate magic code because students, if you're a good student, you're always like, but what is it? You'll learn later. Okay. writing unit tests. So I'm writing a unit test for my sphere. And I've got two tests I've written there, def. I'm defining them as methods. So I've got the first one called test sphere center point returns correct point 3D. Your first thought when looking at this is, that's a hell of a long method name. Yep. But do you know what that tests? Let's try again. Test sphere center point returns correct point 3D. I wonder what that's going to do. Your unit tests, the methods, if I see a unit test with a very short name, 999,999 times out of a million, it's a shit name. You want your names of these methods to be as descriptive as possible. We do follow a little bit of a pattern. Python won't enforce this pattern, but as a convention, there is a pattern we follow, kind of like functionality case, what we expect as like the general pattern. But we'll see more examples of this. There we go. Another thing, and one person discovered this yesterday the hard way, you. It is, whether you like it or not, and I actually think this is stupid, but this is a Python thing, whether you like it or not, the name of the method must start with test. It must be test, yada, yada, yada. It must be. If it's not, and you say run unit tests, Python will be like, there's no tests. Because it just looks for like the function or the method starts with test. Yeah? Why is the equal capitalized? Because we love camel case. You're right. Good observation. This is a funny situation. There might be a reason. Okay, let me actually come back to that in one moment. But that is a good observation. And there may be a reason for this that I'm not aware of, but this does appear to be a break in convention. But be patient for 1 second. So let's look at the first test. What does it do? Well, it's got some setup code. It's very simple setup code, but it does have some setup code. That setup code is make an instance of a sphere. So sphere, point 3D, 3, 2, 1. The values of those attributes, entirely arbitrary. Doesn't matter. I just put in some values to make it happy. 3, 2, 1. And it has a radius 11. Why? Again, it doesn't matter. It's just setup code to make some arbitrary sphere. But when I ask my sphere for its center point, based on how I set it up, where I give it the center point 3, 2, 1, I make a sphere and I say, you have a center point 3, 2, 1. Then I say, what's your center point? It goddamn better give me back the center point 3, 2, 1, right? You might say, isn't that obvious? Yes, and you better make sure it works correctly. So I create a sphere. I immediately ask, give me your center point back. And your center point goddamn better be equal to point 3D 3, 2, 1. They better be equal. Cool? That's what this test is doing. So create a sphere with a center point and then say, no, give me back your center point. Is it what I expected? If your unit tests are, you're like, but that's so simple. Yes, exactly. When we see self.assert equal, that's a method. We call the method within our sphere test class called assert equal. You might now say, where's that I didn't write the method assert equal. You're right, but that's why it came from here. Okay, that's where it is. It exists in this class that we are like inheriting from. Now, your question of basically, why is it this versus, and why is it this and not this? Is that what you're asking? Yeah, I don't know why. I don't know. There might be a reason. It's a bit confusing from the first two. Okay, this is not clear.
Did Python used to use camel case before?
Maybe it did. Okay, why does no one seem to care that Unittest violates Pepe? This is the convention requirement. Am I the one that finds it ridiculous that Unittest, okay, no, because you found it ridiculous too, or at least a big question. Unittest module, okay. It's an old ass thing that exists and they never changed it because if they changed it, it would break all the code that used it from the before time. You could do that and it looks like someone was saying, I did that, but yeah. So to answer your question is why is it doing that? Well, it's following a different convention and it was built in a time when it didn't use the current convention. So that's why. Good observation though, very good observation, yeah. All in one, yeah, it's all over the place. Does that answer your question? I mean, I'm not saying you need to be satisfied with the answer itself, but that is an answer. We are making use of assert equal. That is a method that will check if the two arguments are equal. We are going to see other examples of assert something that we will see shortly. Like there will be like assert true, assert false, and so on. When we call assert equal, it must obviously be going and making use of the point 3D equals, because how else would Python know if these two classes are equal? Well, by how it's defined. But be aware though that this is a test for the sphere class, so presumably the point 3D tests were already written and were correct. So this assumes that the point 3D's equals method is correct. Other questions about what we see here. And the next thing is, okay, test sphere radius returns correct radius. Well, create a sphere and then check. When I get the radius back, do I get what I expect? All right. The key things to note are the tests are methods that belong to the class. Each method's parameter list is just self. It's a method and it doesn't need any parameters, but we might end up be writing unit tests that do take parameters or do have parameters. Each method must start with test. The method names are descriptive, so it's easy to know what it tests, and the test prefix is required, but after test, the name does not matter. So again, I really want to emphasize the name of your unit test, like each method, should be as descriptive as possible. What am I testing? Under what conditions? And what do I expect? In this particular example, sphere radius, that's what I'm testing, the sphere's radius. Under what conditions? Well, there's no real it exists, no special condition. And what do I get? Well, I expect that it returns the correct radius, right? We make use of assert equals, which is a method that we are accessing through the self-reference variable. We inherited this from the unit test.test case thing that we included right here. That's what that meant. So that's why we have access to this method, even though it doesn't seem to exist in this class. But that's fine. Okay, the methods provide a simple mechanism for setup code to be grouped with the test itself. Create a sphere object, test something about that object. Each test should test one thing. This is really important too. You may have thought to yourself, why not just put two asserts and like you can combine this. Look, you created two spheres, they're exactly the same. Why not just do like assert equals, the center point's the same, and assert equals the radius is the same. Like why not just do that in one method? And you're not wrong. You could do that, but you'd be wrong. And the reason you'd be wrong is each test should test one thing. So if the test fails, you know what went wrong. If I have two asserts in there, and the test fails, what went wrong? Well, one of two things. You might say, not a big deal, but then what are we doing here? The point of these unit tests is to make them as like test each functional unit independently so we know if something's wrong, we can find it easy. That's the point of this stuff. So we keep them as separate as possible. So here's some more. Did I skip any? Okay, other than other than those points so far, not much is going on. The basic idea of how we write the test is the same. The only difference is the syntax in writing the test with the unit test. So far, you should be able to like mentally translate like how you were writing your assert tests before to how you would write it like this. I don't mean you should be able to close your eyes and do it by hand right now. I just mean like you should be able to see like, okay, I see how it's like the same thing. I just have to change the syntax to test the same thing. But there's going to be a lot more, it's going to be a lot more verbose. Yeah, but it's better this way, trust me. So here's some more methods we could add. Test equals on equal spheres returns true. So there we go. And again, notice the pattern. What am I testing? Equals. What is the case? This is an example where I have a case. What's the case? Equal spheres. And what do I expect? Well, it should return true. So what am I testing? What is the case? What am I getting? That's what I want you to do for writing your tests. And be consistent. So we have test equals on equal spheres returns true. So sphere A is some sphere, sphere B is some sphere, but they're the same. Point 3D, 1, 2, 3, radius 1, point 3D, 1, they're the same. And if they are the same, and then I call assert equal on sphere A and sphere B, I damn well better get back equal. I better get like true, right? Right. Otherwise, something's wrong. Another test. Test equals on not equal spheres returns true. Two spheres that are not the same. Why are they not the same? Well, they have two different radiuses. I call assert not equals. See, I'm using a different method now. But it's, what am I testing? That they're not equal. Great. You may think to yourself, okay, so if he's testing not equal, see, this is a case where they're not equal because their radiuses are different. Maybe there should also be a test for when the radiuses are the same, but the points are different. And that's great observation. Maybe I am missing that test. Maybe I really should have that test. Maybe I should add more like sub-tests to that test, where it's like, well, when various things aren't equal, to test all the cases of like how equality would be. Test equal on sphere and string returns false. So this is an example of testing if a sphere is equal to something that's not a sphere. Now, don't get this twisted here. The assert not equal, the fact that I've got the string on the left-hand side on line, what is that, 19? Or is that 18? 19? You see I've got the string, and that's actually like the string representation of the sphere. That's not meaningful in any way. I just picked some string, something that wasn't a sphere. I just put in whatever. I could have put in like blah, 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 or the number 14, whatever. It doesn't really matter. I just want to check that a sphere is in fact not equal to something that is not a sphere. So it's just, I just put in that string there. So test equal on sphere and string returns false. Okay, not equal. Yeah, perfect. Cool. And then test repr, arbitrary sphere returns correct string. So sphere, I create a sphere. I call the repr by just a stir of the sphere. And I better get back that string. Yeah? Happy? Sad? Yes? No? Happy. Awesome. So there we go. We got a bunch of tests for our sphere. Above, yeah, there's additional tests. They're effectively testing the magic methods. We're making use of assert not equal. They all start with test. So yeah, this is what I was talking about. The convention that we're going to follow is test, the method, condition, expected. So test equals on equal spheres returns true. Equals is the method, on equal spheres is the condition, returns true is what I expected. That's the convention we're going to follow. Now sometimes, like I just said about that equals, or not equals, where I was like, well, you checked if they're not equal because their radiuses aren't the same, but should you have also tested if they're not equal where the radiuses are the same, but their points, their center points are different? Should I have tested that case? And you're entirely right. And I could have written a whole nother test for that particular case, and that's entirely fine. But Unittest does have a built-in tool to facilitate subtests, where like, what am I testing? Well, I've got another example here. Like, okay, like diameter, right? Consider diameter. What case should I test? Well, we want to check our edge cases and general cases. What are edge cases? Well, test a sphere at the origin that has a 0 radius. And then what's its diameter going to be? Well, if it's got a 0 radius, it's got a 0 diameter. So that's kind of like a special case, right? But we could also test a sphere at the origin with a non-zero radius, right? If its radius is 1 and I get its diameter, it should be 2, right? So we may want to confirm that the center point has no impact on the diameter of the sphere. So test a sphere that exists on an arbitrary location with a 0 radius, and also test a sphere that exists in an arbitrary location with a non-zero radius. So I've already just discussed 4 different particular scenarios. Well, what if the sphere has a radius 0 and exists at the origin? Now the sphere has a radius non-zero and exists at the origin. But I also want to be sure that the center point doesn't screw with the diameter. So let's make a sphere at a non-origin location with a 0 radius and a non-origin location with a non-zero radius. So I've discussed 4 different cases, but I'm testing the same functionality. I'm testing diameter, that I get the diameter back. I could write test diameter, sphere at origin, 0 radius, returns 0. Test diameter, sphere at origin, radius 1, returns 2. Like, I could write all those tests. Yeah. That's exactly what we're going to do, asterisk. It's a for loop with a twist. Where if we did a for loop, let me show you, and then I'll come back and explain why it's not just the for loop. We have to do something special. Yeah. That's yeah. It's effectively what we're going to do, but there's like a twist to it. So here is my example. I could write these 4 tests. Test, 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 test. There's nothing wrong with this. But we could arguably clean up our code a little bit by making use of something called subtests. So what I'm doing is I'm creating a list of spheres, and I'm calling them cases. Now, the names of these variables don't matter. This is what I'm calling them. I've got 4 spheres for the 4 cases. At origin, radius 0, at origin, radius 1. At some point, radius 0, and some at other point, radius non-zero, whatever. You'll also notice I'm testing a float too, which is probably a good thing. And what would I expect every time I run this in a respective way? Well, on the first case, what should I get back? 0. The second case, I should get back a 2. Third case, I should get back a 0. And on the fourth case, I should get back 20.2. Okay? Now, okay, there's also zip. Have I shown you zip before? No? Okay, Okay, before I carry on, let me show you what zip is. Zip is just a handy way if you have 2 lists that are like connected in some way where you can loop over them together. It's just some fancy syntax. Let me show you what I mean. A equals 0, no. A, B, C, D. B equals W, X, Y, Z. Okay, I've just got 2 lists. They're the same length, and for whatever reason, these 2 lists are very importantly connected to me. And if I want to loop over these things, right? Let's say I want to loop over these lists. Like, okay, I've got that, but I want to loop over both of them at the same time. How do I do that? Well, I could do this. And then like print A at I and B at I. Like that'll work, right? There's nothing wrong with that. But what I could do is oh, weird. Okay, fair enough. In there, it's just syntactic sugar to. I'm looping over the things together. That's all. It's like you have them, but you zip them together, like zip, right? You know, what a great name for it, because that's like what's happening, right? You zip them together. Cool? Cool. Now, if you hate zip, if you're like, I hate that, I never want to see that again, well then just do this then. It's fine. You don't need to like zip. There. If you hate zip, just do this then. That's fine. There's nothing wrong with this. Some people prefer this. Okay, that's great. Okay? Any other questions about zip before I go back? So now, okay, zips there. Well, I'm zipping together the cases and the expected. So as I loop over each case, I have the individual case and what I expect. So, okay, for each case expect in zip of the cases and expecteds, this is where I have the important thing. This is where it's like, okay, it's a for loop with a twist. The twist was not the zip, to be clear. That's still just a for loop. But this is where the twist is. We say with self.subtest. And you're going to say, well, what does that mean? It's the magic code. Just go with that for right now. With self.subtest, I'm going to say assert almost equal, expect, and case.diameter. And then there's a 5. Now, what's all that? Well, first of all, let's explain line 17. Assert almost equal. Remember how you really can't compare floating point numbers? And how we would do that, like we'll take the absolute difference, and if it's less than some small amount, that's what that's doing. Assert that they're almost equal. And that last number there on the 5, that's like, well, how precise do you want it? Well, 5 decimal places. That's all it is. All right, so it's to deal with floating point numbers. So assert almost equal. So don't get too worried about that one. But the with self.subtest, this is not necessary. You don't need to write the with self.subtest. And if you don't write the subtest thing, you have exactly what you were saying, linear search / like for loop, the same idea. You would have that. And that would work, but what would happen is if you don't have the subtest, I have 4 cases here. If one of them failed, without the subtest, if one of them failed, it would say, I failed the test, test diameter various spheres returns correct diameter. It would say that test failed. But then you would be left wondering, I had 4 cases. Which one of the 4? When you say with self.subtest, it'll like run them all and be like, well, I passed on case 1, 2, and 3, but not case 4. So it's a way that it just allows it to be a little more specific. It's the magic code. So that's why it's not just a for loop. If it was just a for loop and any of them failed, it would say this test failed. With self.subtest, it runs all 4 of them, and it'll tell you, if any fail, it'll tell you which one. That's the difference. Let's hit a pause on that, and I want to make sure it's clear something to you. Like everything before now, our variables, our types, our functions, our loops, our if statements, writing classes, that's all like base core programming stuff. You're starting with Python and you're building it based on Python. When we're using unit tests, we are using what we call like existing APIs, which means, let me draw it. Like this is kind of what I mean. You load up Python, and for the most part, everything you've been doing, you've been interacting directly with Python. You're writing a function, you're dealing with types, you call the print function, whatever. Now, when doing unit test, we are actually, somebody has already come and built this giant thing for us called unit test. That is built on Python. Okay, this is just your basic Python, P for Python, okay? Now you are being forced to interact with this, not Python, effectively Python ultimately, but you have to deal with the API. Application something interface. I can't remember the P right now for some reason. Long story short, there's a bunch of crap built for you. And you just got to know how to interact with that crap. If you're like, but this isn't as intuitive, it's not, because the earlier stuff with Python was fairly natural. It's because there's like this mathematics to it, right? This won't necessarily be that natural to you because it's like somebody built it. Why'd they build it that way? They just did. And this is how you interact with it. Why? Because. Where the earlier Python stuff, yes, it was designed, it's Python, but it's almost like a little bit more natural, like intrinsically, if that makes sense. Point I'm making is, how was I supposed to like how would I know that? You wouldn't. No one would expect you to just magically know what self.subtest is. You would know it because you go and you read the documentation. But no one would expect you to know it, right? Where like the if, it's almost like if, okay, I get, yeah, I don't need to convince you about if statements. What I mean is if this is like, there's a lot of magic code here. Yeah, because some assholes built a giant thing that we all use now. That's all. Questions about what I mean there? You are now not interacting just with Python. You're interacting with Python and some giant library that exists that if you want to use that library, you got to use it the way they say you got to use it. That's all.
Would you not want to have a counter to have as an input for subtests to tell you which test failed?
The subtest, it'll know. And you can, there's some stuff you can say, like with just subtest, I'm trying to remember now because again, I'm trying to remember the API. Well, you can put in numbers, you can put in like, you can also specify like the case and expected. So it could give you a little bit more information, but it's not necessary because if you don't put anything in, it'll just kind of like try to figure some stuff out for you and it's usually pretty good. But you do have some flexibility with what you put in the with self.subtest. And have at it type thing, yeah. Yeah, so in the above example, each test input. So here's like the general case, right? Here I'm doing it without a zip. So I've got my cases, I got my expected for range and the length of the cases. Obviously cases and expected would need to be the same length. If they're not, you're doing something wrong. So we loop over each case within the subtest. Assert almost equals is, well, what did I expect and what did I get? And here with almost equals, I specify how accurate do I care about. If you're wondering, how did I decide on 5? I pulled it out of thin air. It didn't matter. It was just 5. Good enough. Yeah, without subtest, if one of the tests fails, the rest of the tests would stop and I would not know which one failed. With self.subtest, it works. Cool. And then finally, in order to actually run these unit tests, this really does depend on how you're running your code. If you're not using Colab, figure it out. If you are using Colab, but you were able to figure it out just fine, right? You were able to figure it out. I think the stuff that from Colab will work for you too, but that's not traditionally how you would run it. Did you try like Python-m unit test enter? Perfect. It is, it's lovely. But if you're working in Colab, you basically run this line, okay? What does it all mean? Don't worry about it, right? You could change the verbosity. If you make it a 1, the output will be smaller. If you make it a 2, it tells you more details about what's going on with the tests. But that's what, assuming you have your unit test class and the class that you're testing, you just need to run that line. And then Python goes and runs all the tests for you automatically and it gives you some nice output. After running your test, if everything ran correctly, you're likely going to see something like this, right? Test diameter variance, and it just shows you, okay. And then here it tells me, oh, I ran 12 tests in that amount of time, and then, okay, it gives me some output, whatever. Yeah?
If you have more than one class, this would work.
If I have more than one.
If
Yep, assuming I've got a sphere and a sphere test and a square test and a person and so on and so on and so on, and I run that line somewhere, it'll go and run all of the unit tests that are there. If something went wrong, it'll tell you something like this. Test distance between center various spheres, return correct distance. All right, and it's telling me the specific case where something went wrong. So here, in my example, I broke my function to show you what would happen if it would fail. So all of my tests ran, but one failed. Oh no, but look at what it tells me. It says it failed. Which one failed? I go distance between center various spheres, return. I know where the issue is. And now it's actually telling me, look, which particular case? Well, it was the case where the sphere center point was 0, 0, 0 and the radius was 1. And here the center point was 1, 1, 0 and the radius was 1. And I expected this number. But what did I get? Well, I was expecting that number and I got that number. And it's not correct within 5 decimal places. In fact, this is how different it is. Point being, isn't that a hell of a lot more helpful? First of all, a nice, good, clean way to collect all our tests. Keeps track of everything nicely. Has all the setup code that's required. It's phenomenal. Easy way to run it. Output is fantastic. And when something goes wrong, it tells you what went wrong in detail. We never got this with the assert tests. This is nice. This is how software engineers write their tests, with tools like this. It's so much nicer. So yeah, what do I say? Oh, no. What do I say? Well, to generate the error for, okay. You will see the output of the test a lot more helpful. It tells you which test failed. It also told us which specific subtest failed. It tells us what it was expected. It tells us what it actually got. And just because the test failed, all the other tests still ran. Because remember before, if I had like 20 assert tests and one of them failed, it would stop running as soon as like one of them failed. This, it runs them all still. In fact, you can see that even after this one failed. Oh, I guess maybe it just so happened that was the last test. But it'll run all the tests still. So yeah, it's fantastic. And writing and running these tests might feel like a lot of work. It's just the added syntax is more work in terms of like, I guess, the volume of work, but the added syntax is simple. Writing code is only part of your job if you're a programmer. Demonstrating that your code is correct to yourself and anyone else is your job. Writing the code is useless without tests. I don't give a shit about your code if you don't have tests with it. That's the case. Now, I know, in this class, like, I give you the tests. You're not used to writing tests. But you need to start to get used to writing tests. Any last questions? All right, I'll see y'all later.